Okay, so good afternoon for all. So today we're going to learn about a projectile motion. Okay. Um, this is a extension of the constant assertion that you have learned in previous lesson. Okay. So if you remember, the one you learned in your previous lesson is all about a single component, right? If the question asks for a car that is moved left to right, is all about the question that is from left to right, means that it's just asking in one direction, is uh, x direction, left x to right of the x, left right x. Or if the question, let's say, is somebody is throwing ball upwards, it's only asking for the components of y direction, up y and down y, right? So projectile motion, there will be extension of it, where you have to uh, consider x direction and y direction of an object, right? So prepare, this is the STPM part. Okay, so why is a projectile motion? A projectile motion is a body that is given initial velocity, means that a ball has been kicked and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. Okay, you see there, I put a picture of the one of the game. It was popular, very popular. The game name is, what's the game name? What's the name title of this game?
Angry Bird.
Yeah, it's Angry Bird. Okay, so Angry Bird, how you play Angry Bird? You have to pull out what you call that, the slingshot, right? You have to pull out the slingshot, and then you have to throw a bird, right, across the screen, and then towards the enemy, right? So the path of the Angry Bird, the when you slingshot it, it is the path of the projectile. Okay. One more example is a batted baseball, a thrown football, and bullet shot from a rifle are all projectiles. Okay. The path followed by the projection is called a trajectory. Okay. Angry cat. Okay. So projectile motion, to analyze the motion of the projectile, we use an idealized model. We present projectile as a particle with an acceleration due to gravity, okay, that is constant in both magnitude and direction, okay, and we ignore the effects of air resistance and curvature of rotation of the earth. So we only take account the gravity that is up and down, and we just ignore the air resistance. Why is the air resistance not? Who knows why the air resistance ignore? Why does we ignore the air resistance?
Is this a free fall?
Yes, it is a free fall. Okay. Any more ideas why we um just ignore the air resistance?
It is in a vacuum.
We assume it's in the vacuum, of course. Okay. Any more?
Can we calculate air resistance?
Yes, you have the drag. We call it as a drag force. So actually, if we have the air resistance, okay, we have the drag force, the calculation will be very, very hard. One of the thing we make it simple. Is the simple, the easier to calculate. Okay, and then you see that every time the air resistance will not be very constant. If you go to the room, the air resistance will be different by the air resistance when you're going outdoor. How many people play badminton here? Anyone here play badminton? No one play badminton in this class. Okay. If you see that, if you play with no one, don't play badminton. Are you sure?
Not me.
Okay. Okay. So if you play badminton, there will be a number they're writing on the shuttlecock, like 78, 77, and 76. It means that they have to shoot ball, a shuttlecock that from one end to the one end. If they cannot shoot, they have to change the speed of the number of the shuttlecock. Okay, so it depends on the air inside the what you call the hall. Okay, if you use a lower resistant shuttlecock, the shuttlecock, when they hit the shuttlecock, they will overfly the side of the enemy. Means it goes behind the out of the enemy. Okay, if it was high resistant ball, means that I think the number will be higher or lower. Okay, it will be not, it was nearer to the side of the opponent, right? So they have the numbers of the shuttlecock. Okay, I forgot the numbers, like 77, 78. So they have to manage to find what is the air resistance at that inside in that court. Okay, so air resistance does make a very big effects. Okay, so for simplicity, we just ignore air resistance. Okay, the key to analyzing projectile motion is that we treat x and the y coordinate as separately. Okay. Okay, going to move to another we call it program.
You see projectile motion still set.
Really?
Okay, now change. Now change already.
Change already. Okay. So now we have example over here. So this red thing over here is a ball, right? Assume it's a ball. Okay. And we are watching it in the side view. This is top view, this is side view, behind and front. Okay. So if I run the animation, you can see that this is a projectile motion. Okay. Right. So this is the basic of projectile motion. The ball goes up and then it reach the highest point and then goes down to the ground. Okay. So of course, one of the most important thing is, okay, when you shoot the ball, there will be an angle, right? So there will be the angle. So if you shoot the ball higher or lower, it all depends on the angle. So over here, okay, when you shoot a ball this way, there should be an angle over here. Okay, so it can be higher this way or lower this way, right? So higher or lower. If you see that higher or lower, of course it affects the path of the trajectory, right? So everyone agrees that if you put the higher, the ball will going higher, right? If you put a higher angle, the ball will be higher angle. If you throw the ball lower angle, the ball, of course, the height of the trajectory will be lower, right? So you can see that over here, okay, this is the projectile motion. Okay, now I have to release this thing. Okay, now if you remember yourself, we are talking about x and y component. Okay, so the x component, okay, x component I put as devoted as a blue color over here. Okay, is the x. Okay, so the x, this is the x component. we call the x component of velocity. We are talking about velocity here. The velocity of the x, it never change. Okay, it never change. Why? It's because we ignore the air resistance. If we have the air resistance, okay, at this point, if we have an air resistance in this projectile motion, the length of the blue arrow will be shorter and shorter and shorter, right? If the shorter, it means that the path, the trajectory of the ball over here will be shorter. It means that it doesn't go here. It may be where's it may be came up from this point up and then goes down in this path. So it doesn't land over this side, only land on this side if we have air resistance. But because we ignore the resistance, okay, we ignore the resistance, the path will be longer, and the velocity of the x direction doesn't change. You see, it doesn't change. Okay, one. That is when we're talking about the x component. Oh, it's bad handwriting I have. Okay, again, try to have a good handwriting. I talk about x component. So in the x component, okay, velocity of the x. So we're talking about velocity of x will be constant throughout the motion. That is the law of projectile motion because we ignore the air resistance. Now, projectile motion does not only have x component, it also has y component. So the y component, okay, is here, this part. Okay, so the y component, when you throw it upward, of course the v velocity at the initially it will be pointing up, right? And then it will be 0 at this point. Why 0? Because velocity at the y component is 0. And then it drops down, and then you have velocity v at the y direction is pointing downwards like that. Okay. Any question at this point? No. Right. So
No,
everyone
sir.
is okay. Everyone clear, right? But because we have to imagine this thing in x direction and y direction. Okay, y and x direction does not affect both of them. X does not affect y does not affect x. So both of them are in two worlds. Okay, so this is y. Okay, so because of we have gravity pointing downwards, of course first we have to determine that is pointing up is positive, pointing down is negative, pointing left is negative, pointing right is positive, right? This is the convention of physics. Okay, so pointing up positive, pointing left negative. So now we're talking in y component. In y component, okay, how can you get the velocity? So velocity of a y component, vy. Okay, remember how to get v. How many constant acceleration formula we have?
4.
4. That is first one is
A equals to V minus U over T.
okay. Number 2.
S equals to UT plus 1 over 2 AT squared.
Okay, correct. One more.
V squared equals to U squared plus 2 AS.
Okay.
Then got one more is S equals to 1 over 2 in bracket U plus V times T. That one don't have acceleration.
1 over 2 u plus v
T.
t.
Time.
Okay.
Time.
Okay.
Square or not square?
Okay. So Vy, okay. Which one you should use? We should use V square. V U square equals to U in Y square plus 2AS, right? So now we're talking about Y component. Okay, now I'm going to use another color. Okay, A over here and S over here should be changed, right? Okay, should be changed because we are talking about Y component. So this one should be plus 2 negative G and S is the Y coordinates, right? How high the ball from the ground. So this is the Y. So the whole thing will be V squared, Vy squared, Uy squared plus 2 minus G. Y minus G, who knows? Y minus G.
Gravity
Pointing
down.
downwards. So that's why we have negative G there. Okay. So the Y component, okay, you see that when the U is high, okay, when initially U is high, it will be minus by the negative G over high Y over here. So that's why you can see the green arrow is pointing upwards. So when the Y is small, you can see the coordinate Y is small. When it's initially going up, small minus the negative U, so U is pointing upwards, right? This is big number minus small number, right? Y is a small number minus with the big number, so U is pointing up. Meanwhile, you can see that when it goes up and pointing downwards, when it's pointing downwards, it means that the Y over here, right? The Y over here is already big. Or the Y over here is already big, right? So the U letter is small. So that's why the V letter is negative. V letter negative means that it's pointing downwards. You can see that letter is pointing downwards. Initially, it was pointing upwards, and later is pointing downwards because you can see that the 2 minus GY is the one who has a big numbers over there. Okay. So you can see, okay, remember projectile, and initially V is pointing upwards, and then it's pointing downwards here. At the highest point, V will be 0. Okay, will be 0. Okay, now we have to remind yourself about the trigonometry. Right? When we say that Vy, okay, it is not the resultant of it. Okay, let's say we have on the resultant. Okay, so resultant is the black color now is the resultant. It means that the movement of the ball. Okay, and usually in the question they give you the V resultant as the number. Okay, so usually they can say in the question they give you the, okay, how much the ball is somebody kick with 30 meter per second with angle with 60 degrees. So the question give you 30 meter second is the resultant of the X and Y. Okay, so you can see that this is resultant and this is the vector of X and Y. Okay, now we can understood why we have resultant. The question give you resultant. Now, as I said, we have to use, right? Where's the thing? Oh, remove already. We have to use V, what we have, 10 minutes, okay. We have to get Vy and also we have to get Uy. And we have U in X and Vx. Because of the X does not have any change in the velocity, so we only has Ux, right? x component does not change. V velocity in the x component does not change. So we only have ux, vx we got because it does not change. The thing that changed is vy and uy, because you can see that at any point vy will be changing. Uy is the one when you kick the ball is called uy. So to get the value of uy, you have to use trigonometry, right? How to get uy? So remember, this is here uy. So this is 30, this is 60. Is it cos or sine, cos or tangent to get the value of this green? How to get the value of this green arrow vector? 30 ms is the green, is the black. 60 degrees is the angle to the horizontal. Green is the, how to get the green? Trigonometry. Hello.
Sine, right, sir? 30's sine 60,
30.
sine 60 degrees.
Okay, let's see. 60 degrees, 30 ms. So you want to find this one, right? Why not? So sine 60 is the x, the y over 30, right? Why not?
Yeah, correct.
So 30 sine 60 degrees. So to get the value of uy, so uy equals to 30 sine 60 degrees. Okay, this is how to get the uy. How to get the u in x or v in x? Sorry, u in x. To get the v is x is 30 cos 60 degrees. Right? You want only this component. Okay. It is important to get the uy and ux because later on you have to use v square in y, u square in y plus 2 negative g and h or the y. Right? This uy is the one coming from this number. Then you can get vy. If you cannot get uy, you cannot get vy. Right? Okay. Okay, 6 more minutes. Okay. So every component over here will be determined by its component, x component and y component. So you can see that when it goes up at this point, okay, the only thing that move is vx. Okay, and then drops down, then you have the whole thing over here. Okay, at this point, any question before I proceed? Okay, I am going to play this thing. Any question? Okay, so the concept is every constant motion, constant acceleration motion, that is a 4 that you have learned, must be implied in x component and y component. Okay, so the 4 must be applied to x component and y component to get what is the position, what is the x now, what is the y now, what is the vx now, what is the v in y now, right? There's so many questions can be asked. And how much is the height from the ground, can also be asked. And how much is the range? Range is the furthest it can go. So the range is from here to here, we call as the range, R-A-N-G-E. So the first point to the last point, we call it as a range. How far it can go, we call it as a range. Okay. In x component, let's say v square x equals to u square x minus 2 as Okay, because in the x component, now we got to we are talking about x component. When the x component A is 0, because in x component there are no effect of acceleration, right? Left to right, where got gravity. So when you have 0 over here, everything over here will be turned into 0. So v square x equals to u square x at any time. Okay, forever. Okay, understood? Okay, s equals to ut plus 1 over 2 at squared. This one also can be used in x component, also can be used in y component. For x, sx equals to ut 1 over 2 at squared. Because in x component, left and right does not have any acceleration. This is 0. So the whole thing over here is 0. So sx equals to u. Remember, what is a u? How to get u? Cos or sine? What is a u? Cos or sine?
This u is the x component, right? So it
u.
should be cos.
Okay, cos. So it's v cos degrees times with the t. So ux is v cos of, now you're asking me what is a v? V is the resultant over here. Let's say the one we used just now. The TMS is the how fast the ball is kicked. So 30 ms, 30 times cos theta, how much the angle, and times with the t. So sx is how much is distance. So going to another color. Okay, so xx is how much is its distance. This is x. How far it goes? It depends on the t. 1 second, 2 second, 3 second means that 1 second, x is over here. 3 second, x is over here. It determined by how much the t and how much it times with the v cos theta. Okay. Okay. How about if I talk about SUT in the y component? In the y component, S equals to UT plus 1 over 2 AT squared. Now we're talking about y component. SY, it means that how far it goes up, okay, equals to UT. UT, how to get U in Y? How to get U in Y? V what? Sine theta. V sine theta plus with half. Remember, y component we have the acceleration, so we cannot ignore the acceleration that is negative g times with the t squared. So the whole thing is sy equals to v sine theta minus, okay, this is minus because negative g, right? So we put a minus. Okay, minus 1 over 2 gt squared. Okay, so sy, it depends on this thing and this thing. So either it was above like this, how far it can goes up like that, and when it reached the highest point, at some point the t, you see this is a quadratic equation, like t squared, and it goes down to the how far it can go up from the ground. So this is sy. This is sy. Everything here is sy. How high it is from the ground. Okay, going to. Okay, so we continue with the lesson. So this is the whole thing of projectile motion. Okay, so as you remember, okay, when the things go up, okay, it goes down. Oi, hello. Xander. Okay. Okay, so if you see the motion, okay, it is because of the x and the y is the one who makes the ball move up and down in this direction. Okay, so this is the projectile motion in this way. Okay, So I like to call this one is a full projectile motion. Okay, full projectile motion because it goes up and goes down, and it went from the zero y and goes back to the zero y. So you call as a full projectile over here. Okay. Now we're going to introduce you one more projectile motion. Okay. One more projectile motion. This is also been asked in the SCPM. Okay. So this one is a little bit different. Why is it different? Because so let's say over here we have a same ball or marble, and it was put on top of the table. Let's say this is a table. So this is a table, and this is a table leg over here, and then somebody push the the ball in this direction. Okay, and what happened is the ball will be moving this direction, right? Goes down like that. You see? So the ball goes down. So I can say that this is a half projectile motion because it doesn't go up, it just goes down in the half of the projectile, right? In this way. So how about this one? If you have seen this kind of question, it means that in the resultant is always been in the initially there are no y component. It just been in the vx only. There are no vy, there are no there are no in vy. There are no magnitude in vy, it's only in vx. So the resultant over here, the black color, is only depends on the blue. Okay, as it goes down, there you have the green over here. The green shows that the y, velocity of y, it just appeared. Okay, before it was 0, and then at some point the t then it appeared, then the ball drops down. Okay, how does this green appeared? So this green appeared because v square equals to u square plus 2as. Now we're talking about y component. So y component vy squared equals to uy squared plus 2 minus negative g and the height. Okay, and the height. Okay, so the vy, okay, the vy needs to this is 0, right? Vy was 0 at the initially, and it's only needs it needs the time of the height over here to increase, then the value of vy will be increased. So you can see that at the initial point there are no vy. Then when the h increase, the number of h increase, then you have the value of vy over here drops down. Okay, and remember, just like a full projectile, the vx will be constant throughout the motion because there are no acceleration, no air resistance. Okay, so now we have to give the naming. Okay, either because you can see now we can say that point up is positive, point up positive. In the previous, point right is positive, point left is negative, point down is negative. If you have this kind of question, you can say that point down is positive. Means that v square equals to u square plus 2g and h. Okay, because g is pointing down. Okay, and up is negative. Also, you can determine by yourself. Okay, so if you see some of working example, they say that they use a positive g. Okay, you're allowed because it means that pointing down is positive, pointing up negative. Okay, and v when you pointing down, is positive because, of course, if pointing down will be positive. If the V pointing up, okay, will be negative for this situation. Okay, so it depends. Either you want in this situation, if say you have a half projectile motion, you can use down as a positive, up as a negative direction. Okay, so when you say about positive and negative, why is you have to depend positive and negative because you are using G. If pointing down is positive, then the G over here is positive. If you say that pointing up is positive, then this G should be negative G. Okay? Because G is always pointing downwards. Okay? So it's also obey all the constant acceleration. Okay? V square equals to U square plus 2AS for X component and Y component. S equals to ut plus 1 over 2at square for the X component and for the Y component. Both can be used. Okay. So this is for half projectile motion. Okay. So the big difference is in this kind of question that is it only has Vx only. Okay, it only has Vx. Vy there are only 0. Only happen in Vx. Okay, Vx has a number. Okay. So any question for the half projectile motion? Is there any question for the half projectile motion? Anyone?
No, sir.
No. So everyone good? Okay. So one more tips is X component and Y component. Both of them does not affect any of the components. Means X component does not affect Y component. Y component does not affect X component. But how if the question asks, if the question give you in the X, Y component, and they want to relate with the X. If you want to relate with the, let's say you have Y component, and then you want to relate with the X, the bridge is only time. Both of them had the same time. So if you have X, Y component, you want to go to the X component in the question, you have to go to the what time is it? 3 seconds, 2 seconds, 1 second, and then you can go back to the X. You can't directly go to the X component. Okay. So we're going to see some example of the question in projectile motion. Okay. Okay, can you see the PowerPoint back? Can you see the PowerPoint? Everyone?
Yeah, can see the PowerPoint, sir.
Okay.
Yes, sir.
You have to tell me. I don't have the screen. What I mean your point of view, right? Okay. So see the first example. A motorcycle stunt driver rides off an edge of the cliff. Just at the edge of this, his velocity is horizontal with magnitude 9.0 ms meter per second. Find the motorcycle position, distance from the edge of the cliff, and velocity 0.50 after it leaves the edge of the cliff. So tell me, this is full projectile or half projectile question? Is this a full projectile or half projectile? It's a half. Why you say it's a half?
Doesn't go up, only goes down.
Yes, correct. It doesn't go up, it only goes down. Okay. Now it says find position. Position. Find the distance from the edge of the cliff and find the velocity 0.450 after it lifts on the edge of the cliff. First, what you have to do is you have to sketch. So you can see this is the rider, you have the motorcycle. When they going, so this is the edge of the cliff. When the out, when we reach at this point, is already in half projectile motion. Okay. What happened to the motorcycle next? We don't know, either you're going to die or what. Okay. So first of all, we want to find what is the motorcycle position. Okay. To get the motorcycle position, okay, to get the motorcycle position, you use which one? Either you use X component or Y component. Let's say we want to use X component first. X component. Okay, C-O-M-P, component. So X equals to VOX T. Okay, VOX means that here V or U, we can use also U. It's easier if you use U, right? UXT. UXT. Which X equals to UXT. Who knows this formula came from? This actually formula came from where? This formula came from where? Who knows?
So the velocity formula.
No, it
V
came
equals
from.
to distance over time.
No, it came from S equals to UT plus 1/2 AT squared. Can you see? Because it's an X component, A is 0. So that's why you see this one is put on the equation. Can you see that? Can you see?
Okay, so I
In
can
the
see.
X component, A acceleration is 0. So everything, this term is 0, right? So you only left with S equals UT. So S over here, we are counting in the X component, we're counting the XX or displacement in X. So UXT, right? So everyone agrees is UXT. This equation came from S equals to UT plus half AT squared. Okay. So you have over here is 9.0 times with 0.50. So it is 4.5 meter. So it means that 0.5 second, that means that 0.5 second, it is, let's say over here, oh no, it's already given. Okay, 0.5 second at t equals to 0.5 second, it is 4.5 meter from the cliff in horizontal only. Now we want to find in the y component. So y component, in y component, y equals to negative 1/2 gt squared. Okay, so this formula came from where? Who knows? This one, y equals to 1/2 gt squared, it came from where? Which formula in the concentration? This one came from faster.
The same formula, sir.
Yes, correct. It came from the same formula. S equals to UT plus 1/2 AT squared. Why we left only this term is because U at the X, U at the Y component, U is 0. Because at the Y component, it only went in the X direction. Y direction does not have any number. Correct or not? So U over here is 0. So everything over here will be cancelled. So left it is 1/2 GT squared. Any problem? Anyone have a problem in this example? Any difficulties to
Sir, can repeat why the U is 0?
U is 0 because you see this motorcycle, when it's moved, it's only moving in X direction. Where God is going up, it doesn't go up or it doesn't goes down. So Y
Okay, understand.
component is 0, right? So that's why I put here 0, right? Where is my mouse? Oh, there. That's why over here is 0. Okay. Actually, it's easier if you ask, if you have difficulties, you just already ask me before I proceed to much more high dimension of difficulties. Okay. So equals to -1/2, 9.80 meter per second, and times is 0.50, and then you have -1/2 meter. Okay, so it means that from the ground, from the level of the cliff to goes down over here is 1.2 meter. Okay, so why negative? Because it assumes that pointing up is positive, so pointing down is negative. Okay, and that's why also you can see that it's negative g over here is negative. So we already give the position that is x equals to 4.5 meter and y equals to -1.2 meter. Okay, now we're talking about the distance. The distance is from this point of the cliff. This point of the cliff goes directly to the 4.5 meter and 1.2 meter y. So how to get? Use the Pythagoras theorem, that is r equals to square root of x square plus y square. This is theorem Pythagoras. Okay, easy. So 4.5 meter squared plus -1/2 meter squared. Then you have 4.7 meter. So it means that this black color over here is 4.7 meter from point of the cliff to the point for 0.5 second when it was launched. Okay, done. Distance from the edge of the cliff. Okay. Now, talking about the velocity. What will be the velocity of the motorcycle? This velocity is a resultant velocity. We are not talking about x velocity or y velocity. Okay, so we have to resolve to find vx, and also we have to find vy. Okay, now vx, okay, is v, or sorry, we can raise vx to get after 0.5 second is ux, okay, t xt equals to 9.0 meter per second. Oh, sorry, this is v, this is not x. S is different. Now, just now we use the x, right? So v in the x equals to ux, because I mean the x component, the velocity does not change. So vx equals to ux, that is 9.0 meter per second. Now, y component, vy, okay, equals to negative gt. Okay. Okay, now this one, negative gt, came from which equation in constant acceleration? Negative gt came from where? Who knows? Where this negative gt came from? Faster, everyone.
So the v equals to u plus at.
G equals to u,
Or in other words, a equals to v minus u over t.
u plus
That one.
at, right? Okay, because u in y is 0, right? U in y 0, so we left with at. So there we have negative gt. Okay, going to continue. Okay, so you have over here negative 9.80 and times with 0.50 second. Then you have negative 4.9 meter per second. Okay, so X component 9, Y component negative 4.9. Okay, so what you should do, use theorem Pythagoras, theorem Pythagoras to get the net velocity, the resultant velocity. So V resultant equals to square root of 9.0 squared plus with 4.9 negative squared, and you have 10.2 meter per second. Okay, so at this point, the velocity is 10.2 meter per second. Okay, now we want to find the angle. Of course, we can find the angle because we have a V in X, V in Y. So tangent theta equals to a negative 4.9 divided by 9.0. So you have negative, angle will be negative 29 degrees. Okay, so it's over here is 29 degrees below the horizontal. There you have it, right? Any question? Any question, class? No. As usual, no. Okay.
No.
No.
Not yet.
Okay, this is second example. Okay. The second example, a batter hits a baseball that is leave the bat at a speed of V0 equals to 37 meter per second at angle of 53.1. A, find the position of the ball and its velocity, magnitude, and direction at t equals to 2 seconds. B, find the time when the ball reached the highest point of its flight and its height at this time. C, find the horizontal range R, means that the range, the starting point to the drop point in the x direction. The horizontal distance from the starting point where the ball hits the ground, the ball velocity just before it hits. Okay. So first, what kind of projectile is this? Half or full? Is it half or full? Hey.
It's full, sir.
Half, sir.
Half?
Full, right?
Full or half?
Full.
Why call it half? Why say it's half?
Hit the baseball, it will go up, right?
Okay. Of course, go up. Cannot go down.
But then you
And then
can't
it comes
get
down.
far.
Okay, so
You hit the
actually,
thing up.
yes, it is going up. So the sketch is like that. Can see the diagram? So it was deflected with angle with 53.1, and the given is 37.0 meter per second. So this is 37. So this black thing is 37.0 meter per second. Okay. Of course, you know that this 37.0 you have to convert into Vx and Vy, right? Okay, if you didn't convert it, you cannot answer this question. Okay, now, of course, you have to find Vx, I mean Ux. In Ux, okay, Ux is U cos theta. I mean, I want to find how much is the here Ux. Okay, Ux cos theta. So Ux cos theta is 37.0 cos with 53.1. Okay, cos 53.1. So Ux will be 22.2 meter per second. Uy, okay, is U sine theta is 37.0 sine 53.1. So this one will be 29.6 meter per second. Okay, so we have understanding that pointing up is 29.6 meter per second velocity. Pointing to the right over here is 29.6 meter, right? Oh, 22. It is 22. 22.2 meter per second. Okay. Now from resultant, from the vector, we have get the x and y. Okay. From this point, we can use x component and y component of acceleration, constant acceleration formula to get the value. Okay. Now we want to find the first, find the position. Okay. Find the position of the ball and its velocity. Position of the ball, one part. Velocity, one part. Okay. I have to erase this thing. I want to get the number. Still want to get the number to view the number over there initially. Okay. Now, to get the x, okay, the x component, okay, at that point is negative ut, okay, ut, uxt. So it is 22.2 meter per second times with 2 seconds, because you say that how much is after 2 seconds, 2.00. So x will be 44.4 meter. Okay. Y equals to uy t minus 1/2 gt squared. Now we're talking about x, y component. It has gravity, right? So y will be 29.6 times the t, that is 2 seconds, minus 1/2, 9.80, and times with the t, that is 2.0 squared. There you have 39.6 meter. So at 3 seconds over here, x is 44.4 in this range, and y, the height of the ball, is 39.6 meter height. Okay, done with the position of the ball. Velocity, how to get the velocity of the ball in x velocity? Velocity in the x is v ux, right? Because in the x direction, v does not change, so it will be same as 22.2 meter per second. And vy depends on the gt, right? So vy is equal to u y, that is uy minus gt. Okay, so this one will be 29.6 minus 9.8 times with 2.00, and this is 10 meter per second. So in the y, it was moving in 10 meter per second velocity, and x is 22.2 meter per second. Okay, I'm going to clean this one. I have to clean. Okay, now because we already have the number, so v equals to square root of x squared plus vx squared plus vy squared. So if you do 22.2 squared plus 10 per meter squared and square root it, you have 24.4 meter per second. Okay, and angle is y over x, vy over vx. There you have 10.0 divided by 22.2. There you have 24.2 angle. Okay, so at this point, it was in 24.2 angle. Okay, So B, find the time the ball reached the highest point as flight and his height at each this time. So here, what is the height? So at this point, Vy equals to 0, right? So at this highest point, Vy equals to 0. It doesn't have any velocity at y. So Vy equals to 0. So Uy equals to Vy minus Vy equals to Uy minus Gt equals to 0. Okay, so Vy equals to 0. So T1 equals to equals to Uy over, this one you just arrange the formula, over G. Then you have 29.6 meter divided by 9.80. Over here that you have 3.02 seconds. It means that time over here, when it reach the highest time, equals to 3.02 seconds. Okay. So how much is the height when it reach the highest point? So we use the time to find the x, right? Remember, we can say to use the time to find the x. Okay. So from there, from t equals to 0, t equals to 3.02 seconds. So the height h equals to Uy t minus 1 over 2 gt squared. Okay, so 29.6 times with 3.02 minus 1 over 2 g 9.80 times with 3.02 and squared. And you have height is 44.7 meters. So it means that the highest point is 44.7 meters. Okay. C, find the horizontal range R. Means that this point to this point, how much is the x distance? Okay, easy. What we have to do is, we know that at these 2 points, y equals to 0, right? So y equals to 0 is equals to U y t minus 1 over 2 gt squared, and it is t and v naught y minus 1 over 2 gt squared. Remember, this is quadratic. Okay, so if you solve the equation, you can have, this is quadratic, it's a max, t2 equals to 0, t equals to 0, or t equals to 2v naught y divided by g, and it is 2 times 29.6 divided by 9.80 meter per second. There you have t equals to 6.04 seconds. So the roots is either 0. Of course, t0 you have over here, right, on the left. T0.64 is the one on the right. So either 0 or 6.02 seconds. Okay. Now, because we already have the time, we can find how much is the x range. This is y component. Now we want to find the x component, right? Okay. So you use y to find the time, and from the time we use the x component to find the range left to right. Okay. So how to find the range after we have the time, because the total time is 6.0 seconds. Okay. So the range, or s, equals to u in the x t. So 22.2 times the t is 6.04 seconds. So you have 134 meters. So you know that from here to here is 134 meters. Okay. Next one. How ball velocity just before it hits, means that what is the v over here when it hits? So Vy equals to Uy minus GT, okay, equals to 29.6 minus 9.80 times with 6.0 for second. There you have negative 9.6 meter per second. So negative 2/6 means that at this point, V equals to 29.6 meter per second. Okay. So that is the answer for projectile motion. Okay, as I said, you have to separate both the world. X component has its own world. Y component has its own world. So if you want to convert X to Y, you have to make a time as a bridge. Okay, because both of them had the same common time. Okay. Any question? I'm going to end this question. It's already 40 minutes in Zoom. End this meeting. Any question? Anyone? Okay, if no question, I'm going to stop here.